Block diagram reduction. In this, the block diagram can be reduced to find the overall transfer function of the system. So there are few rules for reducing the block diagram. So rule 1 is combining the blocks in cascade. So here G1 is one block and G2 is another block. A is the input. So the output here comes A into G1. And here AG1 is multiplied with G2. So the output is AG1 into G2. So what for this diagram, the output will be A is the input and G1, G2 are cascaded. So the output will be AG1 into G2. And second one is rule 2, combining parallel blocks or combining feed forward paths. So here is the input A. There are two blocks G1, G2 which are connected in parallel, and there is a summing point with two positive signs. So here we get input is multiplied with block G2, so AG2 and here AG1. These two gets added and the output becomes AG1 plus AG2, or else you can write it as A into G1 plus G2. And if we change this diagram, we get here G1, G2 are connected to a summing point. So you will get G1 plus G2. Here we given the input A, so the output becomes A into G1 plus G2. The same response will occur in both the cases. So moving to the rule 3, moving the branch point before the, so if we move the, so this is the branch point. If we move this branch point before the block, so how it gets changed means, so here this branch point is moved over here. So the block gets here G. This is A. So A into G is the output here, and here also A into G. Next, moving the branch point ahead the block. This is the branch point and we need to move this before the block. So branch point moved ahead. So the block gets changed here. That becomes 1 by G. This is the input A, and here we get A into G, and here we get AG, and here output becomes AG by G. So the output is A. Next, moving the summing point ahead of the block. So moving this summing point ahead of the block means it should be moved here. So this is the summing point. This is the input A. Here it comes AG plus BG. That is equal to G into A plus B. Next, rule 6, moving the summing point before the block. Moving the summing point before the block. Okay, this should become here. First draw the summing point. Next, block G, and here B. This is A. and across B the block gets changed, becomes 1 by G. So here both are summing points positive. So here the output becomes B by G, B by G, and here A plus B by G, A plus B by G, A plus B by G. From the summing point we got this output, and here we get A plus B by G into G. So by if we solve this we get AG plus B. Seventh rule, interchanging the summing point. So there are two summing points, A, B and C. Now I will change this. So we can change in this way. This is the summing point. A is the input. This is another summing point. So here in this we are getting B signal here. So I will change the summing point over like this. So this is negative and this is positive. And this is B is the input. Here it is positive. So the output for this summing point is A minus C, and for this the output overall output will becomes A minus C plus B. A plus B minus C is the output. This way we can change the summing points. Next one, splitting summing point. Splitting the summing point. So in this way we can change we can split this one. Splitting the summing points. Input A positive, and this is another signal, and here this is C. So A plus B minus C is the output. This way we can split. Next, combining summing point. We need to combine this one into single summing point. So this is A positive, B, and this is C negative. So the output is A plus B minus C. Next, elimination of negative feedback loop. We need to eliminate this negative feedback loop. So this is the input R and this is the response output C. Here the C is feedback. So C into H gives here input. This is the feedback loop. So input R minus feedback R minus CH. This both combined. So R minus CH into G. Or else we can derive this one. C is equal to R minus CH into G, whereas C is equal to RG minus CHG. C plus CHG is equal to RG. If we take common C, 1 plus HG is equal to RG. Now output by input. So C by R is equal to G by 1 plus GH. So this is the transfer function for this block diagram. So G by 1 plus GH. R, this is C. For negative feedback, we'll get positive G by 1 plus GH. Elimination of positive feedback loop. So for this, we'll get the output as G by positive feedback loop. So 1 minus GH. R and C. So here for the elimination of negative feedback, we'll get g by 1 plus gh.